While classical and recurrent novae are driven by the awesome power of nuclear fusion, there's another class of stellar outburst that, despite its name, is caused by something entirely different. These are the dwarf novae. They also occur in binary systems with a white dwarf and a companion star, and they also involve an accretion disk. However, the outbursts of a dwarf nova are much less energetic and far more frequent, sometimes occurring every few weeks or months. The brightness increase is more modest, typically by a factor of 10 to 100 rather than the thousands or hundreds of thousands seen in classical novae. They are fainter, but they are persistent. The secret to a dwarf nova lies not on the surface of the star, but within the accretion disk itself. The explosion is not thermonuclear, it's mechanical. As material from the companion star spirals into the disk, it gets stuck in a way. The viscosity or stickiness of the gas in the disk can change dramatically. For long periods, the disk is cool and dim, and matter slowly drifts inwards, building up in the outer regions. It's like a cosmic traffic jam. The gas accumulates, and the density within the disk increases. This build-up of material creates an instability, a tipping point waiting to be reached. When a critical density is reached, the nature of the disk changes abruptly. It triggers a thermal instability. The temperature suddenly skyrockets, causing the gas to become much more effective at flowing inwards. All that material that was patiently waiting in the outer disk suddenly rushes towards the white dwarf in a great tidal wave of matter. As this wave of gas falls inwards, the friction and compression release a tremendous amount of gravitational potential energy in the form of light and heat. This rapid dumping of matter onto the white dwarf causes the entire system to brighten dramatically. This is the outburst that we observe as a dwarf nova. Once the bulk of the built-up material has been cleared from the disk, the system settles down again. The disk cools off and the gas flow returns to its slow, quiet trickle. The cycle then begins anew as matter once again starts to accumulate in the outer disk, slowly building towards the next instability and the next outburst. So, while a classical nova is a nuclear bomb going off on the star's surface, a dwarf nova is more like a dam bursting within the accretion disk. It's a fascinating example of how complex physics in these swirling disks of gas can create their own spectacular, albeit smaller, cosmic fireworks.